Make the beep.
You always say that.
Hey, there we go. All right. How do we find the area of this rectangle? Length times width. And we have to differentiate length and width because L and W are different. That's why we have to do length times width. But what if it's a square? Why would I call it length times width? They're the same thing, right? In a square. A square, L equals W. So I could have WW or LL because they're the same thing. So what we do is instead of using L and W, we say a square side squared. And that is where the term square and square root comes from. The number square roots come from building actual squares, from when they were building stuff back in the day. If you're provided with the area of a square, how can you determine the side length? What do you got to do? Right. Square root of the area equals side length. On a model in real life, something you can hold in your hands, okay? This symbol in math class is asking you to, now, what is that symbol asking you to do? Somebody is going to say what that symbol means, and that's the wrong answer. What is that symbol asking you to do?
Divide by 2.
What two numbers multiplied?
There you go. That symbol is asking you to find two identical factors of, I should have had an X in there, of X. The key here is they must be identical. That is why you can have a negative square root or you can have a square root, but you cannot the square root of a negative number, because there is no way to have the same two factors there, because two of the same factor will always multiply to a positive. Okay? This is not allowed. This is, and this is. Everybody good? Aye. How do I find the volume of a prism now? Well, I know there's W. I know there's L. What's left? Height, H. I do L times W times H. What if it's a cube? What do I know about L, W, and H? What do I know about L, W, and H in a cube? They're all the same. L equals W, L, W equals H. So I'm allowed to go S times S times S. Math guys are lazy, so we write S cubed. And that is where that comes from. So if area square root finds me the side length, what do I do with volume? What do I got to do to volume to get the side length? Cube root. So it's still a root, but now I want a cube. So if this symbol is asking for two factors, what is this symbol asking for? Three factors. Now you guys are smart kids. If this is 2, I got to wait till my updated screen unfreezes. If this is 2 and this is 3, we're going to come back to that actually. I've jumped ahead. I forgot this part. The small 3 is called the index. And the index tells you how many factors. So, perfect square or perfect cube is any real number which has an integer root. Remember, an integer is a number with no decimals. So, I call your attention to this. If that means 2 factors, and that means 3 factors, what does that mean? 4 factors. And then what does this mean? Nx. That means n factors. Everybody cool? It's the only time in math where we don't write a number 2. Every other time in math, if we don't write the number, what is it? It's a 1, right? 7 is really 7 over 1, isn't it?
Yes.
7 is really 7 to the first power, isn't it? 7 is really 1 times 7, isn't it? We never write the 1. This is the only time that we don't write a 2. Because could we ever have a 1 as an index? No, because you need factors. There has to be at least 2 of them. Everybody cool? Okay. So now, this sentence is supposed to be on the next page, but I will never test you on this because this is not a class in memorizing. But just like your life is made easier if you know how to ride a bike, you don't need to, but life is easier if you can. You don't need to have these memorized, but life in math class for grade 10, 11, 12, university, forever and ever and ever forward, anything you do mathematically, your life will be made easier if you have these memorized. And when I say memorized, I mean memorized, not like you could say, what's the square root of 361? 19. That's how fast I mean for memorization. It'll just make your life easier. Will it make it better? No. Will it save the world? No. Will it make your math life easier? Yes. And since you're all here in the summer, I assume you want your math life to be easier. So I would recommend memorizing these. And I've given you space to list them if you wish. If you don't wish to list them, don't bother. I'm going to have them on the screen up here. 1, 1, 2, 4, 3, 9, 4, 16, 5, 25, 6, 36, 7, 49, 8, 64, 9, 81, 10, 100. 11, 121, 12, 144, 13, 169, 14, 196, 15, 225, 16, 256, 17, 289, 18, 324, 19, 361, 20, 400. 21, 441, 22, can't remember. I had block out there. Till 25, that's 625. And then the cubes, 1, 1, 2, 8, 3, 27, 4, 64, 5, 125, 6, 216. I'm so fast, I'm faster than the computer. 7, 343, 8, 5, 12, 9, 729, and 10, 1,000. Again, I will never test you on it, but it's a good idea to know them. And what we're about to do is a reason to know them. We're going to do a bunch of stuff on the bottom of this page. So I'm going to make sure you guys get that written down if you're wishing to write it down. If you're not, of course, you don't have to. Because I have it written on the screen right there. I shrunk it down because I want you to be able to see that at the same time as you can see these. Okay. One of the skills that is seriously lacking in you people's math ability is the skill of estimating. You do a whole page of work, you get an answer, and that answer is totally wrong, but you have no idea if it's totally wrong and you hand it in anyway. That is because you are not estimating. You will notice every time we've done something that has anything to do with measurement, I've always said, have an estimate first, right? That way you don't tell me it only takes 15 steps to walk to Chilliwack, right? Gotta use your head. So if you were doing high-level math, and it takes a half page of work, but you can do an estimate so you know what you're going to be close to, then when you do that half page of work, if your answer's way off, you know you can go back and check and find your mistake. This is a real good time to practice that, and here's how it works. I want to estimate the square root of 72. I don't want to get out my calculator. I'm at the hardware shop. I've got some measurements. I need to estimate something. So I'm going to estimate the square root of 72. Where does 72 fit in on this line? It's right there, yes? Here is 72, correct? So, 64, 81. Square root of 64 is 8. Square root of 81 is 9. 72 is somewhere in the middle. How far is it in the middle? It's almost exactly in the middle, isn't it? 64 to 81 is 17, right? That's 8 past that. It's almost exactly in the middle, isn't it? So shouldn't its square root be almost exactly in the middle up here? Is it a little bit past? So our guess would be what? Don't go to a calculator. What would you guess? 8.6. Now, when you go to your calculator,
8.6.
square root 72, 8.48. 8.5 is much closer. The point I'm trying to make is, let's say I'm doing a crap load of work and there's a square root involved. If I have a vague idea of what it is, I know it's about 8.5. Now I can do some estimating with it. What's 180 going to be? Where does it fit in? So it's 13, 14. 13 is 169, 14 is 196. Is 180 closer to 13 or closer to 14? It's closer to 13, isn't it? So it's going to be less than 13.5, maybe 13.4. And then we can check. Square root 180. Holy crap, 13.4. Everybody with me? Do the next 5. Watch out for D, E, and F. They're cube roots. We're going to do one more thing here, and then I'm going to give you some work, and I'm going to shut up. everyone should have estimated around what I have in blue. Can everybody estimate a square root? Excellent. Now we're going to do a little bit of work with this. Some stuff that is a little bit important. You guys should have a very little bit of blank space below at the bottom of your page, yes? I want to do a couple of things in there. First, I want to do this. This is the first thing I want you to see. Square root of x over y. Does that square root cover the whole thing? Yeah. So that's really the square root of x over the square root of y. Everybody cool? All right. Here's the next thing. Can you tell me the square root of 900 without going to your calculator? Huh? 30. It is 30. Because that is the square root of 9 times 100, correct? Square root of 9 is 3. Square root of 100 is 10. 3 times 10 is 30. Everybody cool with that? Yeah? Okay. Next thing I want to do is ask you this. Can you tell me the square root of 0.25? 0.5. Because this is really the square root of 25 over 100, yes? The square root of 25, that's really square root of 25 over square root of 100, which is 5 over 10, which is 1/2, which is 0.5. Is everybody cool with that? Okay. So the last thing that always screws kids up is this. If you know the square root of 0.25 is 0.5, what then is the square root of 0.025? Follow this pattern. This is really what? 25 over what? 1,000. What's the square root? So that's really 25 over the square root of 1,000, yes? 25 as a square root. Does 1,000? No. 100 does. 1,000 doesn't have a square root. 10 times 10 is 100. That's 1,000 doesn't have a square root. It's not perfect. So this one is irrational, like we were talking about yesterday. But now see if you can put it together. What about this one? So 0.25 got me 0.5. 0.025 was irrational. What about 0.0025? $25 over 10,000, which is 100. So this becomes 25 over 10,000, which is 5 over 100, which is 0.05. That one worked. Why? What is different here, here, and here? Yeah. Yes. The amount of, not zeros, decimal places. 2, 4. They both worked. 3 didn't. Will 5 decimal places work? Nope. Will 6 decimal places work? Why? 6 and it's even. Because we're splitting it into 2, right?
Wait, so if the decimal places is even, that means
You have the possibility of getting a square root. If the decimals aren't even, you cannot get a square root, no matter what. Don't even try. It's irrational. What about cubes? Odd? So that's odd. 25 has a cube root?
No,
No, but 1,000 does,
no,
right?
that's right.
So this has a possibility.
It depends on the number.
Depends on the number under there. Everybody with me? So if I ask you a square root of a decimal, first thing to check, does it have an even number of decimal places?
Or 1 on top, it can-
If it has an even number of decimal places, is it possible that it's a perfect square? If it's even. Yes or no? Yes. Then you check the number. 25 is a perfect square, so this one works. What if I had 0.28? Even number of decimal places, maybe, but 28 is not a perfect square, so it's not going to work. With me? Okay. So that's all I would like to talk about. Now you guys are going to do 93, 94, and 95 as homework. 93, 94, and 95. Page 93 to 95 as homework. Meanwhile, I'm going to be marking your quiz. If you need me, come and talk to me. If you don't, do your work.